As a trap designer, you have to be able to calculate as well. One of the principal portions of designing a specific spike trap is to ensure a slow death. To accomplish this, the trap intends to push the would-be grave robber to the wooden walls. Now you must calculate the speed of rotation to keep the grave robber from slipping. Also, one must know the centripetal force and centripetal acceleration. Focusing on the linear velocity and the radius of the trap, one can calculate the centripetal acceleration. Without knowing the linear velocity, this becomes difficult. So looking at the force of the wall pressing on the robber accounts for this. In the end, the normal force of the wall pressing on the robber is where the centripetal force comes from. Taking the weight of the robber and applying it down towards the spikes and into the wall gives normal force. The last part needed is the force that points towards the center of the room. This is calculated as mg sine theta times cosine theta equals mv squared divided by r, which is the mass times velocity squared divided by the radius. Mass cancels out. All one would have to figure out is b. Since the gravity, radius, and angle are all known, once knowing b, you can solve the angular velocity, which is expressed as rotations per minute. The second part of being able is once the room stops spinning, you don't want the robber to fall quickly to death. Calculating what the net force would be, including the friction between the leather and the wood, and knowing the distance the robber will cover while sliding down the spikes helps solve the final velocity, with nothing else slowing them down. So calculating the momentum of the robber when they hit the spikes. One can calculate the desired moment if they were going 2 meters per second. To figure this out, the difference in the momentum, aka the impulse, this is used to calculate the number of flaps you would use to slow the robber down to 2 meters per second or less.